Now we're looking at part 2 of chemical bonding. So in this part over here, we'll be basically going through, right, whenever you deal with any chemical bonding questions, what should you do? So first step, you need to determine the number of valence electrons of an element. So before you can identify the number of valence electrons of an element, you need to first identify the proton numbers, which is the atomic number, as the proton number will tell us the number of electrons, since number of protons is equal to number of electrons for an atom. So after you are able to identify the number of protons, number of electrons, then you'll be able to identify the electronic configuration. But before you can write down this electronic configuration, right, you'll be required to know, right, how many shells are there. So the first shell, right, can occupy up to 2 electrons, 2. And for the second shell onwards, third shell onwards, you'll be occupied up to a maximum of 8 electrons. So this is what you need to know now. So after you have write out the electronic configuration, you'll be able to know the number of valence electrons. Because the electronic configuration, so if you look at your mock quiz 2, this is an example of an electronic configuration. Basically, for the first shell, you put up to 2 electrons, and after that you put it in the way of in the order of 8, so 8 and 6. And normally for electronic configuration, the last number that you see in the electronic configuration will tell you the number of valence electrons, which fits the criteria on the number of valence electrons in the outermost shell. So by using the electronic configuration, you'll be able to determine the number of valence electrons, which then represent the group number. So this is how elements are being arranged in a periodic table based on the number of valence electrons. So to determine the number of electron shells of an element, for those of you who are unaware, the number of electron shells, right, tell us how many circles for us to draw. So in this case, you also tell us, right, where are the electrons located? So if it's the first electron shell, you can fill up to 2 only. And for the subsequent electron shell, you can fill up to 8. So by determining the number of electron shell, you'll be able to know how much electrons to fill in for each of the shell. First shell will be 2 electrons. The subsequent second and third electrons will be 8 electrons. So another way is you can just look at the periods, which is the row of the periodic table. So if it's the first row, it means it has only 1 electron shell. Second row means 2 electron shell, and so on and so forth. So after considering all these questions, you'll be able to tell whether they are metal or not metal. So how do you tell, right? You just be looking at the number of valence electrons. So if it's 1 valence electrons, means it's group 1, and group 1, 2 and 3, they are metal. And for group 4, 5, 6, 7, they are non-metals. So this is how we classify whether an element is metal or non-metal, just by looking at the valence electrons. And next question will be, how many electrons needed to lose, gain, or share when you form a ionic bonding or covalent bonding? And how to determine the number of atoms needed for each element? So we can use this cross-transfer method. Okay, just to add in one more thing. In order to know how many electrons needed to lose, gain, or share, right, we need to count what are the maximum number of electrons in each shell. For example, if you need 3 more electrons to make it to 8, that's why you gain 3 electrons. If you have only 3 electrons in the outermost shell, then you lose 3 electrons to obtain the maximum number of 8 or 2. So it also depends on for metal, they tend to lose electrons, and for non-metal, they tend to gain electrons, as it is easier for metal to lose electrons, for example 1, 2, or 3 electrons, as compared to gaining 5, 6, 7 electrons. There are too much energy is needed. And this is the same applies for non-metal. So it's easier to gain 1, 2, or 3 electrons or 4 electrons, but for non-metal, if they want to lose 765 or 4 electrons, it will be too much energy needed. That's why they tend to gain electrons instead of losing electrons. So if you want to know about how to do it for an ionic compound, stay tuned for the next video. Thank you.